Shalom to you and welcome. In this video, we will solve real-life application problems involving right trigonometry. We'll solve problems involving right triangles, angle of elevation and depression, and bearing. So again, angle of elevation has to start from horizontal line and go up, elevate, go up, line of sight. Angle of depression has to start from a horizontal line also, but goes down. Okay. So watch that. And bearing starts from zero, starts from north, and then go clockwise. True bearing goes all the way from 0 to 360. Compass bearing goes northeast or northwest and southeast or southwest, but all with reference to the north and south. All bearing problems uses north and south. Okay, a 22 feet flagpole casts a 62 feet shadow. Calculate the angle of elevation. Okay, let's draw a picture. Always draw a picture. It's very helpful. We know a flag is vertical. So this will be the flag. And then the shadow will be horizontal on the floor. So the flag and the shadow is going to form a right angle. Well, the angle of elevation, the sun is going to be up here somewhere, atop the flag. So the angle of elevation is going to start from horizontal and go up. So it's this angle here, that line. So let's call it theta. So the flag is 22 feet and the shadow is 62 feet. Okay, which trig ratio do we have to solve this? Well, the angle is here, opposite and adjacent. Opposite and adjacent, the two legs, so it's tan, TOA. So tan theta is opposite, which is 22, over adjacent, which is 62, sorry. But we are finding the angle, so let's take the inverse of tan. So theta will be inverse tan of 22 over 62. Plug into your calculator, get about 19.536, which is approximately 20 degrees. Okay. An ocean liner, which is a type of boat, is 9 miles due west of a lighthouse A. So we start from a lighthouse A. If lighthouse A, it's over here, let's write it as A. So, and on that lighthouse A, there will be arrow. This is north, and that's south, and that's east, and that's west. So the lighthouse A, the ocean liner is due west of. So starting from the lighthouse A, the ocean liner will be due west. So it's going to be in that direction. Due west. So let's call the ocean liner L, somewhere here. And at this point, it will have its own north and south and the west also. Now, the ocean line is 19 miles. So we write 19, the distance it is from the lighthouse A. It says lighthouse B is 32 miles due south of lighthouse A. Okay, from lighthouse A we go south. So we go south. So lighthouse B will be somewhere here. And of course it's going to have its own, we still have the north there, we have south, we have east, we have west. So, and it is 32 miles. Find the bearing of lighthouse B from the ocean liner. Now, the key is from where. So the from is where the angle is going to form the ocean liner. So we are looking for the angle here. So B and liner. So let's draw a line. They are from B to liner. So, but the angle we are looking for is from ocean liner. So the from is the origin. So from the ocean liner, what is that going to be? So we are looking for this angle here. Okay, let's draw that in black. There. That's the angle we are looking for. All right, so and then we are looking for the distance from the lighthouse B to the liner. So we are looking for this here, B. Okay, of course, the two lines west and south forms a right angle there. So we can use Pythagorean theorem right away to find the distance because we know the two sides. So what's that going to be? D is going to be the square root of 19 square plus 32 square because those are the two legs. So D is about 37. To simplify, 37.221, which is approximately 37 miles. Okay, so next we find the angle here. Okay, how do we know this angle? All right, so far we know right here, this angle here is 90 degrees. Then let's find this one. This one, call it theta. So again, we have opposite and adjacent. So that's tan. So we call tan theta is opposite, which is 32, over adjacent. Again, the one that is adjacent has to connect with that angle. So theta is going to be the inverse tan of 32 over 19, which is about 59.30. So now, if we take that and add it to 90, we get the whole angle. So if we had the bearing is going to be 90 plus 59.3, which is about 149.3 degrees. Okay, next, to take off from an airport at 9:15. So we have a few background work to do here first. Okay, so we're going to find the time it took both of them first. So 10:45 minus 9:15. So that's gonna be 30 minutes, 1 hour. So which is 1.5 hours, or 3.5 hours. Well, we want it to be in hours because our rate is in mile per hour. We want them to be in the same unit. Always check for that. Next, we are going to find the distance for plane A. Distance is rate times time. Now, for plane A, distance is rate is 190 times 3.5. So that's going to be 285 miles. For plane B, again, distance is rate times time. and it's going to be, the rate for this one is 160 times the same time, so it's going to be 240 miles. And next we're going to use this information now to draw a picture considering their bearing. So if we draw from the airport, this is port, and that airport is going to have its bearing of north, south, west, east. Okay, let's see. And then it says the first one has the course bearing of 86. Okay, 86 is close to 90. 86 is almost 90, so it's going to be about here. So this here is 86 degrees. So this is airport for flight A, and the distance it traveled for A is 285. So let's write that down. 285 miles. Okay, and then the second one has a bearing of 176. 176 is almost 180, just a little 4 less than 180. So we do 4 less than 180. So it's going to be about here. So this is plan B, and the distance it traveled is 240. So 240 miles here. Okay, so if we notice, here is 4, that little one is 4 also. What do you think? So this is the whole of 180 minus 4 would give this angle right here. Let me draw it in red or different color. Okay, this angle right here is going to be 90 degrees, because from here to here is 180 minus 4 is 175, 76. So, and then we have this 4 off here. Okay, so we are asked to find how far apart these are. So how far apart? Let's label it F. And since this is a right angle, we know the two sides. We can use Pythagorean theorem. So F is the square root of what? 285 squared plus 240 squared, since both of them are the two legs. So we're gonna get 372.59, which is approximately 373 miles.